this is the weak base. Okay, so it is the same as the strong base. When we want to calculate the pH of a base, we have extra one step. So let's write the target. We want to calculate pH. When this is a base, we always start with the pOH. To get the pOH, we have to have the hydroxide's concentration. Okay, so this is ammonia. It is partially ionized, so we have to get the concentration of the hydroxide ion that will be liberated by this weak base, okay, by constructing our ice table. So the ice table will be NH3 aqueous plus with the H2O liquid turns to ammonium plus hydroxide ion. So initial concentration for the ammonia is 0.2 molar, dash for H2O, 0 for ammonium, 0 for hydroxide. Concentration change is minus X plus X plus X for hydroxide, so that the concentration at the equilibrium 0.2 minus X, X and X. So to get the concentration of the hydroxide ion, here we have to solve what is the value of X. How to solve the X is by using the Kb that is given. So we have to write the Kb expression. So base dissociation constant Kb is equal to the expression concentration of ammonium multiply concentration of the hydroxide over concentration of the NH3 ammonia. So Kb is given as 1.76 times 10 negative 5 is equal to X square over 0.2 minus X. So to solve the X value, we can make assumption, we can simplify the calculation because of the Kb that is too small, 10 power of negative 5. So we assume that 0.2 minus X is almost equal to 0.2. So write our assumption. Since Kb is too small, 0.2 minus X is almost equal to 0.2. So we can proceed with the calculation. So X then equal to square root 1.76 multiply 10 negative 5 multiply with 0.2. Press the calculator, we'll get the answer. The value of X is equal to 1.87 times 10 negative 3. So this value is actually the concentration of the hydroxide ion. So now we have solved the first step. Let's move to the second step. After we got the concentration of the hydroxide ion, we can calculate our pOH. So pOH is equal to negative log concentration of the hydroxide ion. So it is equal to negative log 1.87 times 10 negative 3 is equal to 2.73. So complete the second step and let's move to the target. We want to calculate the pH. So pH is equal to pKw minus pOH, which is equal to 14 minus 2.73, then we get the pH of 0.2 molar of ammonia is equal to 11.3. So that's how we calculate the pH of the weak acid and weak base. So I want you to check the follow-up problem. Okay, on the calculation of the pH POH by using the Ka and Kb. Okay, and I want to stress with you the relationship between Ka and Kb for the conjugate acid base pair. Okay, when we have the weak acid, for example Ha, undergo dissociation in water, so Ha will turns to A minus. It release its H plus to H2O, so H2O turns to H3O plus. So since that this is the acid dissociation process, so the K expression will be Ka, acid dissociation constant. And we know that this is the conjugate base of the Ha, which is acid. This is acid, so A minus is conjugate base. So when this is the conjugate base, when it is undergo base dissociation process, so A minus react with the H2O liquid, it will turns to Ha plus hydroxide ion. All base will liberate hydroxide. Okay, if we sum these two equations, we'll get the overall equation. By cutting Ha with Ha, A minus with A minus, then we'll get H2O plus H2O is equal to H3O plus hydroxide ion. So this is actually the overall equation of these two. Okay, remember the first step is actually the acid dissociation process. Second step is the base dissociation process, and they are actually conjugate acid base pair. So the Kw, which is the K for the overall equation, is actually equal to the product of the multiplication of the Ka plus Kb. K for the first step multiply with the K of the second step. Okay, so to recap, Kw is equal to Ka multiply with the Kb. It's going down here. Okay, and we can use this relationship only if we have the conjugate acid base pair, means that they have to be conjugate pair. Okay, so let's look at to the sample problem 18.8 first. We have a propanoic acid CH3CH2COOH. Ka is given as 1.3 times 10 power of negative 5. The question asks us to calculate what is the concentration of the H3O plus. Okay, as what we have done just now, what we have discussed just now, we know that when we have the propanoic acid, this is a weak acid, means that we have to construct the ice table. Okay, because not all propanoic acid will dissociate into ion. So we construct the ice table. Propanoic acid plus H2O produce H3O plus propanoate ion Pr minus. Okay, so initial concentration of the propanoic acid or HPr is 0.1. This is what we have here, 0.1 molar. Okay, 0 H3O plus 0 Pr minus. The changes negative X for HPr, positive X for H3O plus, positive X for Pr minus. At the equilibrium, 0.1 minus X. At the equilibrium for H3O plus, X. And for Pr minus, X. So the question asks us to calculate the concentration of the H3O plus, means that we have to solve our X value. So to solve X, okay, when we look at to the Ka that is given 1.3 times 10 negative 5, this is a very small Ka value, so we can assume that 0.1 minus X is almost equal to 0.1. So the X can be neglected during our calculation. After we neglect the X, so we will have Ka equal to concentration of the H3O plus multiply concentration of the PR minus over HPR concentration is equal to x square over 0.1 only, no more minus x. Then solve the x value. Lastly, we get the x is equal to 1.1 times 10 negative 3 molar, and this is actually the concentration of the H3O plus that the question asks us to calculate. So let's look at to the sample problem 18.7. So the question asks us to find the Ka value, okay, from the pH that is given. So the pH is 2.62 and the concentration is 0.12 molar. So this is the phenyl acetic acid. Okay, so when we write the phenyl acetic acid dissociation, it is HPAC, simplified as this, HPAC plus H2O produce H3O plus PAC minus. So to calculate the Ka, we have to have the concentration of the H3O plus, PAC minus, and HPAC at the equilibrium. So construct the istable. Initial concentration of the HPAC that is given is 0.12 molar, changes negative x, plus x for H3O plus x for PAC minus. At the equilibrium will be 0.12 minus x, x, and x. Okay, the pH is given as 2.62. Okay, since that the pH is given, we can calculate the concentration of the H3O plus. So the concentration of the H3O plus is equal to 2.4 times 10 power of negative 3. So this is actually the x value here. So the same as the concentration of the PAC minus, 2.4 times 10 negative 3, and plug in the value of x in this calculation. Okay, so 0.12 minus 2.4 times 10 negative 3. Then just press the calculator. We'll get the Ka is 4.8 times 10 negative 5. Sample problem 18.11. Okay, we have dimethyl amine here. The Kb is given and the question asks us to calculate the pH of 1.5 molar this dimethyl amine. So this is as what we have done before. We have to construct the istable, put the target to calculate the pH. We have to calculate the pOH first. Why we have to calculate the pOH first? Because this is base. If we have weak acid, we don't need to start with the pOH. Okay, so to calculate the pOH, we have to calculate the hydroxide ions concentration. So construct the istable. Dimethyl amine plus H2O produce CH3, CH3 and H2 plus and hydroxide ion. Initial concentration 1.5 as what's given here. 1.5 0 0 minus x plus x plus x. So at the equilibrium will be 1.5 minus x, x, and x. So to get what is the concentration of the hydroxide ion, we have to solve the x value. So to solve the x value, we'll use the Kb that is given by writing Kb expression. So the Kb expression is equal to concentration of CH3 and H2 plus multiply with the concentration of the hydroxide ion over concentration of the CH3 and H. It is equal to 5.9 times 10 power of negative 4. So we plug in the value, we make assumption, we neglect x, so that the Kb is equal to x square over 1.5. Then we'll get the x is equal to 3 times 10 power of negative 2. And this is actually the concentration of the hydroxide. So with this, we can calculate the pOH, and also lastly, the pH is equal to 12.4. As what shown in this slide, okay, the textbook calculate the concentration of the H3O plus, okay, by using the equation H3O plus equal to Kw over OH minus. Either one, we can use this method, or from the concentration of the OH, we calculate the pOH, and then we calculate the pH. Okay, as what shown here is, from the concentration of the OH minus, calculate concentration of the H3O plus, and then calculate pH. Okay, personally, I prefer to use this method. It's up to you. So with this, we have finished all the examples on how to calculate the pH of the strong acid, strong base, and then relationship with the Ka and Kb. So please answer your tutorial regarding these subtopics. So see you. Assalamualaikum.